Before we jump in, I just want to cover one thing. So there's two different ways you can work on a radio. You can do a repair or a restore. A lot of the guys that we know on YouTube that do this stuff have different ways of doing it. Some restore them back to the way they were when they were new or close to it. Some of them just repair them and get them working. Neither one is wrong, neither one is right. It really is your personal preference. I prefer to restore them and get them back to what they used to look like when they were new. And you'll notice that I've shined this chassis up, only half of it right here. So right up to this can has been shined up, and I use something called Mother's Mag and Aluminum Polish. This stuff is amazing. So it goes on, it has a chemical reaction, and it turns black, and you wipe it off and you come right down to the shine and you buff it up. I also had to replace one of these IF cans, the filter, the actual can itself, not the coil. And the reason why I had to do that is because one of the cans was actually split in half. And, you know, to this day, I'm still baffled how that happened. But it did. And, you know, for me, I want to have something that looks better. So that's why you'll see this silver can here. I've replaced it. This one is also bent up and chewed up, and I'm going to replace this one as well. Not sure what this material is, but it does not shine. So I don't know if it's tin or aluminum. Not sure what it is. So we're going to replace that as well, and we have to finish cleaning the chassis on this side only. All right, so keep that in mind. Either you're going to be a restore or repair. Either one works. It's your choice how you want to do it. The tips that I'm giving you will help you with both of them. All right, let's get on to it. Hey everybody, welcome to episode 3 or part 3. So let's recap what we learned in episode 2. So what we did was we checked the power supply and identified what kind we had, whether it was a transformer, a series string, or a curtain burner. We identified the transformer windings. We had the 5-volt winding, the 6.3 volt winding, the high power winding, and of course the primary coming in. We tested each one to make sure that we had continuity. We tested the field coil on the speaker, and we spoke about replacing the electrolytics so that we can get to our next step. Okay. So let's talk about where we are, what we've done so far, and then we will start to move into part 3 and learn some stuff. So I did, excuse me, end up replacing the electrolytics in here, and you don't see them, and I'll show you why in a moment. Let's flip it over. So what I ended up doing in this radio is I ended up using a tube shield. I'll tilt this up so you can see it. I also work on guitar amplifiers, and there's a certain tube called an EL84, which is a very tall output tube. And this is a tube shield that's actually made for that. So what I did was I took a tube base, 7-pin tube base. I drilled a hole straight through the pins. This way I had holes coming out the other side, and I mounted my caps inside here. And I'll show you what this looks like. I haven't glued it yet. And here I have a pair of electrolytics. 2 10s. I have a little piece of insulating paper here between the two of them. This is my grounds coming down the top, and they run down through the tube socket and attach to the bottom of the radio. Now what I'll end up doing before I wrap this radio up is I'll put some JB Weld on this cover so that no one can open it. But you'll see I've identified what's in there, the voltage, and that's what we're going to run with on this radio. So we have our electrolytics. They're neatly on top. And you'll see I put a piece of rubber grommet here just to close that top up so we don't get any prying fingers. So the electrolytic on this radio has been completed. But we need to take a look underneath and observe a few things here. So the first thing I want you to pay close attention to is these caps. Okay? Now if you recall, when we did in part 1 we said it looks like no one's been in here. Well, I was mistaken. One of the reasons why we try to learn. These are not caps from 1930s, 1939. These caps were replaced probably sometime in the 40s or 50s. And the way we know that is caps in 1939, especially when this radio was made, were wax caps. And I'm sure many of you have seen what wax cap and what they look like. But that's what should be in here. And what you'll see is we have something very different in here. We have something called a NEC. NEC, probably not the same company as the one we're familiar with, or it could be, who knows. We've got a bunch of those in there. Here we have a Mallory. This is a plastic cap. And then we have this old Sprague, which is probably very old. It may be one of the originals, because that is a wax cap with a paper on it. So that could be original, and this one could be original, but the rest of these are definitely not. So this goes back to the theory of knowing what you're looking at before you start working on it. So let me draw your attention down here to this tube socket, and we're going to move this out of the way so you can get a close look down there. Right there is the tube socket that I installed for the electrolytics. And I'm not sure how well you're going to see this. This black line right here is one leg of the capacitor. The red is the other, and then this is the ground, right? And you'll notice that I've installed a terminal strip. Let's see if we can move that out of the way. I've installed the terminal strip right here, and I have all of my connections. This is my ground connection, and this is my connection here for my electrolytics, okay? So this red wire that you see here goes to the actual electrolytic cap. This one here goes to the 6 SK7, I believe, and the other one comes up here to this terminal strip right over here, and we now have our capacitors in circuit. I've also replaced this green wire. This green wire was frayed beyond recognition. And there was also a black wire underneath. Let's see if we can find it for you. It's this black one right here. And this is what was there under the radio. Okay? So you have to remember, when you work on these old radios, the wire could be deteriorated, and it certainly was in this case. Now, we certainly have to do a lot more work under here. But one of the things that we have to think about is, where do we go from here? So we've done a visual inspection. We've made any repairs that we could possibly make. We've changed these wires. We put in the electrolytics. And now we have a fork in the road. Now there's a couple of ways we could go here, and we have to think about what's the best way to go. So most people, including the way I used to work on this, would just go in and just replace everything, right? Get rid of all these, get them out. Before I try anything, make sure they're all done. Test the resistors, replace ones that are out of tolerance. Also check the transformer and coils, the IF can, one's here and one's here. Doing this, we know all the components are new and test good, right? You think that's a good thing. But I think we can think about using an alternate method. So the first thing we want to do is visually verify that the earlier modifications made by somebody else are back to normal. I've done that here. That's evidenced by the work that I did on this electrolytic cap. I'm sorry about the camera shaking. I'm not sure why it's doing that. So that's evidenced by the way that this electrolytic cap has been put back in circuit. One's going here, one's going here. We also want to make sure that there's nothing that looks really damaged, and in many cases you won't find it on these capacitors because they're not the original wax caps. But the original wax caps, you would notice bubbling, dripping of wax, that kind of thing. So anything that that shows a sign here of not being good or being marginal, you'd want to replace that before you do a test. But in our situation, everything visually looks okay. It's a mess, but it visually looks okay. Now, but of course, by doing the global replacement of things, you actually run the risk of doing miswiring and making mistakes. So essentially, doing it this way, you at least understand if the radio is going to work the way it is. Okay? So we're never going to power it up directly into the wall. You've noticed that I put a 3-prong cord here. You always put, let me pull this shot back a little bit. You always put the hot side to a switch. All right, always. Hot side to a switch. In some cases, it'll go to a fuse to a switch. You put your neutral side here, which in this case is on the rectifier tube, and you find a good ground, which is right here. I actually have it grounded to the same bolt that's holding in the transformer. So now that we have the 3-prong cord in, we deem the power supply is safe, at least as safe as it can be to work on. We've tested it, we know it works, right? So our next step or course of action is going to be, let's throw it up on a dim bulb tester. Now, if some of you have never heard of a dim bulb tester, basically what you're doing is you're making sure that any voltage or current that runs through the power cord in this radio goes through a light bulb. Why do you want to do that? Well, if your transformer is shorted, it'll save it. It'll prevent it from happening, and we'll show you what that's supposed to do. There's actually a diagram here of what one looks like, and I'll show it to you. So it's right here. This is the configuration, and you'll see you've got a plug, a switch, a bulb, a socket, obviously, and an outlet. So that's what it looks like. So what we're going to do is we're going to connect our radio to the dim bulb tester, and we're going to show you what that looks like and what we get out of it. Okay, and remember, we want to attach a speaker when we do this. So let me get it set up and we'll be back. Okay, here's our dim bulb tester, and you'll see this is something I built myself. It's got the standard light bulb in it. I'm using a 75 watt bulb. I've got an on-off switch, and I have the radio plugged into this box. I have this box plugged into a variac. If you have a variac, that's great, right? Variac allows you to vary the voltage. You can go from 0 to, mine goes up to 130. And allow you to bring things up slowly just in case there's a problem and turn it down slowly. If you don't have a variac, you at a minimum have to use this dim bulb tester. So before we turn anything on, we also want to monitor our B plus voltage. Let's look about where we're going to find our B plus voltage on this radio. So if you look here, here's our rectifier tube. We're going to find B plus voltage right here at this first cap. So if you remember, I put a terminal strip in the radio. We're going to put our meter right here, the red lead, and we're going to clip the black lead to the chassis. So we're going to monitor our voltage while we do this, just to make sure we have B plus. So let me get that connected. Okay, we have our meter connected. It's right here. And we're going to make sure we're on DC volts. We've got this connected. I've also connected an antenna wire in the event we get something out of the radio. And we're going to turn on our isolation transformer. Now when we do this, we want to pay careful attention to the chassis right here. We want to look in there. If we smell anything, if we see sparks of anything, we shut it down immediately. What we're going to expect to see is this light bulb will glow. If it glows really bright and stays bright, you shut down immediately. That means you have a short. If it comes up and it stays at a very low glow, you should be okay. So our variac is turned on, and we're going to start off by going very slowly up to 30 volts. Okay. Let's see if I could show you this here real quickly. You may notice it, but we're starting to get a dial light, which is good. At least we're getting our filament voltage. Our meter still says that we're at not even a volt yet. Let's go up to 50 volts. You notice our light bulb is perfectly dead, as it should be. Our dial light has gotten a little bit brighter. Let's go up to about 70 volts. Now we're at 70. Still no sound from the speaker. You'll see our B plus is starting to rise. We're at 50, 60. We're starting to hear some radio. We're currently at 70 volts AC. Let's go up to 90. You notice our light bulb is still nothing there. We're at 120 volts DC. I don't smell anything. I don't see any sparks. Let's go up to 100 volts. Now you notice our light bulb is starting to glow a little bit. That's okay. I just noticed that our B plus dipped a bit and came back. Now what's normal with tubes like this, when they heat up, the voltage is going to drop. That's normal. We're going to have to monitor that. So we're at 145 volts at 100 volts AC. Let's go up to 110. A B plus is at 160. It's holding steady. Light bulb looks good. And finally, let's go up to 117. You notice our radio gets a little bit louder when we do that, obviously. Our light bulb is staying nice and dim where it should be, and we're getting about 180 volts DC. We've got some problem with B plus here. Did you see that? The light bulb got a little bit brighter. We're going to shut it down. So what you just observed is interesting. So we've been able to bring up our B plus, but there's something interrupting the B plus supply. Now likely I could tell you it's probably arcing happening underneath the radio. There are so many different solder connections that someone put in this radio that are very close to each other. There's probably some arcing going on that you can't see and I can't see. But that's enough to drive what we just saw from the B plus perspective. So we did a visual of the cleanup, but we need to do a little better job now. So we're going to go in and do another inspection. Before we do that, I want you to observe that we're leaving our meter connected and you're watching the voltage come down for B plus, which is good. It means that the caps are draining and it's safer to work under the radio. If your radio doesn't drain the caps, you need to discharge them. Okay? So we're going to do another visual underneath and I'll come back and show you what that looks like. But you just saw the care and the caution you need to take when you check these things for the first time. Be right back.